Hi, this is Phil. Welcome to another video. In my previous video, I went through how I've implemented this main game loop here, and I focused on the map area of the code. In this video, I'm going to show you how I've implemented the player movement and the player bullets. So if you have a look at the player ship, you can see at the back we've got an animation going for the back burner, and when you move forward, that animation changes, and there's a different animation there for when that's moving forward. You can also see that the movement is sort of dampened, so when I'm letting go of the keys, it's still sort of moving. It slows down to a stop, and the same when you first press it, sort of accelerates. So you get this sort of dampening, smooth movement. And when you press space to fire, you'll see that there's an animation at the front that's sort of the muzzle flash of the weapon, and then also when it hits the terrain, there's also another animation that's played. You can sort of see that there. So I'm going to go through how I've done that, and also as you know, when this hit counter fills to the top, the ship is upgraded. So for every ship upgrade, there's a new set of images that need to be used to show a different ship. The back burners are different for each ship, and also the weapon as well is sort of more powerful and upgraded. And I'll go through how I've done that. So what you don't want to do is end up in a situation where you're having to write different code just to display different graphics. So none of the code changes. I'm just changing some variables that tell the existing code to use a new set of images. So I'll show you how I've done that, and also how I've done the collision detection. So when you hit the terrain, you can see there that there's another animation going on that shows the sort of the red flash. And when the ship actually explodes as well, there's also another set of explosion images that's different for each ship as well. So I'll go through how I've set all that up. So let's have a look. So all these variables here look after the ship and the player health, the animations, all the number, the image numbers for all the animations. I'll just go through each one of these. So PX, that's basically the X screen position, and PY is the Y position on the screen. These next set of variables are used in the move calculations. I'll go through those in a bit more detail. These two, the first one, P speed, that value is used to add to the current position for the up, left and down movement. And the PB speed is the speed that's applied when you move the ship forward. So when you're moving forward, it actually moves a little bit faster than when it's moving up, left or down. So that's why I've got two variables for the speed. These are just offsets. So when you've got this X and Y position for the player, and I need to position the muzzle flash, or the source of where the image is going to be for the projectile from the weapon. I need to be able to figure out where that is in relationship to the position of the player. So that's what they're used for. Now they're all zeros here because all these are basically set up based on which ship is currently assigned to the player, and because the sizes of the images change, these are different for each ship, the offsets. Player state, so there's 3 states that are used in the game. 0 means that the player's alive, 1 means they've been killed, no, they've exploded, and 2 means that it's game over. And player health, that just tracks how much health the player's got. Hit points, let's just go back to the game. Just explain the health side of things. So up here you've got that's the overall health of the ship. This is the hit points, and then underneath that is the hit counter. So as you're taking damage, this will start reducing. Once that gets to 0, then the ship will explode, and part of the health will be reduced. So if you watch what happens there, that goes down, and then the health gets reduced. Once that health is gone, the green health has gone down to 0, that's when the game's over. And if I had something to shoot at, as you hit and destroy enemies, this bar goes up once you get to the top. That's when your ship gets upgraded. So that's what these 3 variables are tracking. So player hit is just a trigger that I use in the code that basically triggers the animation that you see when you hit. So that sort of red pulsing flash. So that triggers that. Damage amount. This is set mainly by enemy bullets. So what that allows me to do is different enemies can damage the ship at different levels. So that's used in the enemy routines. Now BBI, this is basically a starting image index. So all the images are numbered. If we have a look in the images folder, so you can see there that number 10 is basically the level 1 ship. So that's why that's set to 10. It's the base image for the player ship. And what you'll see that in sequence after that is a set of other images that all relate to the back burner. So these are the 4 images for the animation for the back burner. So they're numbered 11 to 14, so there's always 4. And after that you've got the boost animation for the back burner. So another 4 images there. When the ship explodes, you've got those. So that's what's shown for the ship exploding. And when it's taking damage, you've got this next set of images there. As you can see, that's just an animation. I'm just using those frames to show that. And so that's all for level 1. You've got, so it starts at 10 and ends at 41. So the reason why I've got this variable BII, and that's because if I want to play the let's say the boost animation there, what I'm doing in my code is I'm just adding 5 to the base image to get to that image, and I know the next 4 frames is where I want to be for the boost animation. Now, the reason why I've done it like this is so that when the ship is upgraded to a level 2 ship, if I've got all my images for the level 2 in the same sequence as this, all I need to do is change the BII to the first image, and then the rest of the code will just work off that. So if I scroll down to the level 2 ship, you'll see there's the, I think that's level 2. Yeah, so level 2 ship starts at 300. So BII would be set to 300 there. And then you can see again the next 4 are for the normal back burner images, and then the next 4 are for the boost, and then you've got the explosion, which is the same number, same set of images, and then the take damage images there. So there you go, that's how I've done it. And you can also see, you know, as I'm adding more ships, I think there's 7 in total, I've got the same format. You have your base image there, 396 would be for this level ship. Then you've got the next 4, and so on. So it's quite important to, if you're going to do something like this where you've got, you know, you play a character or whatever upgrading, you don't want to be having to write different code for the different images. So this is the system I came up with. I just numbered everything in sequence, and yeah, you need to plan that out really if you're going to do it like that. So that's what BII is for. PMF is used in the draw code. So as I'm animating things, PMF just basically holds the current image to put on screen at the player X and player Y position. And initially that's set to whatever the base image is, which is the current ship. So PBBF is the back burner frame number, and like I said, what this is doing is just adding 1 to the base image. So like I said, it would give you that value there, 11 for level 1 ship. So for the back burner image frame, it would be initially set to 11, and if we wanted to get to the boost, we'd be getting to that. So we'd be adding 5 to BII. So this next one is just using the animation code, and if you're moving up, left or down, that would be set to 0. So it knows that it needs to show this animation. Use those 4 frames for that animation, and when that's set to 1, so you're moving forward, it would then trigger to start showing that set of images for the animation. So that's all I'm using that for. It's just a flag, internal flag. Also, all the images have got a hotspot. So in the code, let me see if I can find where I'm setting the hotspots. Yeah, so here. Yeah, player images 10 to 41. So I'm setting the hotspot to be the center of the image. So when you're putting things on screen, it defaults to the top left hand corner of the image. I'm just using the center position here. So in the middle of this, these are 128 by 128. The XY of that is the center. So if I just couple of these. So if that's the image, 64 pixels, sorry, 128 by 128 pixels. The center point here, that's where the hotspot is there. So the player X and Y position would be at this position. So these offset variables. What I need to know is if I want to put this animation of this boost, if I just open that, if I copy that, put it in a frame. So if I just use the player XY position to put that on the screen as well, it'd end up there. So the offsets basically allow me to work out that that needs to be at the back of the ship there, and how many pixels away from the player X and Y position that is. And again, because the ship size change for the different ships, this changes as well. So that's why there's a variable for that there and there. And because the images for the boost are different sizes, there's a different offset for the boost images. So I'll show you this one there. So you can see, to move that back to the right position, it's going to be different to the image that's smaller. So that's why there's a different offset for the boost animation. So this one just controls the speed of the frame animations for the back burner. The next couple for the shield. So you can see in here there's a shield animation. So those 8 frames are basically overlaid on top of the player ship, and the each image is cycled through to give you that effect. But also these are rotated as well. So that's what the PSF and PSR are, ship rotation, and which frame it's currently showing. The has frame is just a flag within the code to show that the player is currently shielded. And then the next couple are used to remove the shield after a certain period of time. And then the last couple, these are used in the shooting routines, as it controls the rate of fire for the player. As you know, when you can collect speed ups or upgrades during the game, and it basically just changes this value to get a faster rate of fire. PW refers to the player weapon. There's currently 5 levels in the game, 5 levels of weapon, and you start off at 1 and then that goes up to 5. And player ship, as I've said, there's 7 different levels, so these two basically control which weapon and which ship is being used in the game. So again, most of these are set here, but they're just declared, but most of these values are actually set when the current level of the game is set as well. So let's jump to the draw player routine. So if we look at the first thing this go sub does, so it checks the player state. If it's less than 2, so it's either a 0 or a 1. So a 0 would be that it's live, and player 1 is that they've died or the ship has exploded, and 2 is game over. So it just checks it's one of those states. We don't put the player ship when on screen when it's game over. But when it's exploding, we still need to put the bob on screen because we want to be able to show the explosion animation. So that's why that's like that. Now PMF is the current frame number, and because I'm using, and the animations are using values that are less than 1, the actually decimals. So I need to convert the int or the value to an integer so that it relates to an actual image number. So that's why I've got the int around that. So this piece of code here just looks after the back burner animation. So the first thing it's doing at the top, this is the PBBF that holds the current frame number for the back burner. And as I said earlier, there's a variable that holds the speed, and I'm timesing that by the delta time. And I went through delta time in the previous video, so if you want to know what that's all about, you can have a look at that video. So like I said, these when the ship is either stopped, moving up, left or down, there's a different animation being played to when it's moving forward. So that's that flag there. So when it's 0, it's not moving forward. And what I need to be doing is I need to just show those 4 frames. And what I'm doing a bounce animation. So I'm starting it there, and I'm animating up to that one, and then I'm animating back down. So that's what I'm doing. So when it is stopped, these 2 lines of code just control resetting or changing the direction of the animation in effect. So you can see this value here becomes negative once we've reached the base image index plus 4. So like I said, that would be 10 plus 4. So once we've reached that value, it changes that to a negative, so that when we're adding that value to the current frame, the value starts tripping back down to there. And then again, this if statement here just checks to see if it's less than equal to the base image index, which should be down here. So once it's either that or less than that, it'll change the speed to positive again. So then it'll start going back up. So that's what they're doing. So like I said, Bob 1 is assigned for the player. Bob 2 I'm using for the back burner. And this is where the offset comes in. So when I'm putting the back burner on screen with this Bob command, I'm using the current player X position, but I'm taking off whatever the offset has been set for the back burner for that particular ship. And again, I'm using the int there because this would be a really small number. So this ends up being a decimal number, and obviously the image numbers are whole numbers, so that's why I've got an int around that again. So that looks after the animation for the back burner. So the next piece of the draw player code looks after animating the player hit animation. So when the player ship is hit, I basically need to cycle through these frames. So instead of just showing that, it jumps up here it'll show these, or it'll change the current player image to these numbers. So all this code's doing is changing this PMF value. So player hit is set to 1 in a different area of the code. So when your player's hit by a bullet, or if you've hit the terrain, this gets set to 1. And because this is getting called every frame, while that's set to 1, it will then do this. It will start adding this value to the PMF value, and you know, PMF, player hit and PMF are set in the collision detection code. So for level 1, PMF would be set to 30, and again that would be calculated based on adding 20 to the base image of 10 to get to 30. So for level 1, PMF would start off at 30, and that will start increasing to start showing these different images. And the timing of that is basically done here. So this 60 times the delta time controls how fast that sort of trips over into the next images. So once it reaches the end, and so you can see there, once the PMF has got to the base image index plus 31, so it's always the same number of images. So as we know, for level 1, BBI is 10, so you add 31 to that, you get to 41. So it knows it's got to there, and it resets the player hit flag. So the next time or the next frame it comes into here, it won't do this, and it sets the current frame for the player back to the base image, which would be 10. So once it's done this, the next frame, this PMF then would be set back to that image. There's also a sample played when you're taking damage. So I've just got a procedure there that takes in a value of a sample to play. I've put that in a procedure because I could have just wrote sampler here and a number, let's say. I could have done that, but if I've got these dotted around all over the code, and I want to in the future implement the ability to turn off sound effects, for example, I'd have to then go and find all my samplers and put some code around it to either play it or not based on a configuration setting. But because that's all in one place in there, I can just put an if statement around the sampler in one place to turn off all sound effects. So that's the reason I've got a procedure to do that. So the next piece looks after the player shielded animation. So as I said before, there's this has shield. It's just a flag. It's either a 0 or a 1. When it is a 1, it means the player is shielded. And very similar idea. All this is doing is when that's set to 1, I'm using a third bob, so bob 3, and I'm putting bob 3 at the same position as the player X and the player Y, and I'm just cycling through another set of frames, which are these here, 80 to 87. So that just gets put at the same position as the player ship, and the animation cycles through these and then repeats. So this isn't a bounce animation, it just goes to the end and then gets set back to here. It cycles through them. But these are also, these are rotated as well, so they rotate clockwise. So that's why I've got this PSR value, PSR variable, and that just continues to rotate. So there you can see putting the bob 3 on screen, and I'm also rotating it based on what the PSR value is. So the shield timer, and this is set whenever the player is shielded, there's a shield collectible in the game. I think you get shielded for 15 seconds. So in that piece of code, this would be getting set to 1, and shield timer would be set to, or shield time, I think it is. Yeah, shield time would be set to 15. So what this is doing, it's incrementing the shield timer, which starts at 0, and then once it's gone above what the shield time is, and then play a sample, an audio sample, it'll reset that flag and then remove the shield from the screen using the bob off. So that's how that works. So that's everything in the draw player. Just basic looks after the animation side of things. So it's not doing any collision detection or anything like that. And all that's done in the next procedure. So we've got update player. So the first thing we're doing here, we're checking to see if the player has a shield or not. We're checking that the player is alive. And this is checking for collisions with the terrain. So in my first video, I showed you the tile map editor and how I'm using that to put the terrain on screen. So I'm also using that to check when the player is colliding with the terrain as well. So what this is doing, if we have a look at the tiled map editor, so this grid, this would be 0, 0, and as this is moving along, the player ship could be anywhere in here. So what I need to figure out is if the player ship is hitting any of these cells that have got terrain in them. So because the ship isn't 64 by 64, the way that I've done this, I've basically said that the X and Y position of the ship, I'm basically looking at the cell, not the cell that this falls in, but the cell that's in front of the ship. And also I'm checking the cell behind the ship. So if the ship was here, like for example, it was on this cell, it could be spanning 3 cells. So my code actually checks, it works out the X and Y position of that part of the ship and the X and Y position of the back of the ship, and then looks at what cell that falls in to see if there's any terrain in there. So I've got 2 positions. I've got the check front, so it just gets the tile value, and this is basically using the player X position, which is just the screen position. It's adding 14 to that to get to the front part of the ship, and then it's also adding the level X position. So I went through what level X is in the previous video, but it's just whereabouts in the map we are. And then I'm dividing that by 64, which is the size of each map cell, and that would basically give me an XY map position of where the front of the ship is in the game. And then obviously the tile ID that comes out would either be 0 or it'd be one of these other values that's assigned to these other tiles. And so checking the front, checking the back, grabbing those 2 cell values out of the map, and if they're not zeros, which are what these are, I'm setting the damage amount to 1. So that's, as I said earlier, that's the amount of damage to apply to this player ship, and it'll go to a separate part of the code to look after applying that damage to the ship. It looks after reducing the health, triggering the damage animation that I was telling you about up here. So player hit and the PMF would be set within this player take damage. So I won't show you that, but that's basically what that's doing. And now we're getting into the actual movement code for the player ship. So this is where the PBA, this is that flag I was telling you about in the draw code at the top. If PBA is 0, it plays this animation. If it's not 0, then it'll do the boost. So every frame, that just gets reset back to 0, just in case, once you stop moving, it needs to be set back to 0. So we're just making sure the player state is 0 and the level hasn't been completed. And then we're checking the state of the keys then. So if key 37, that's the left key, spelt that wrong. And we've also got the check of the right key. Now, the reason I've got an if and else around these two is that you can't move left and right at the same time. So if you're moving left, you no need to check for the right key, and the same with up and down. So you've got these if and else. So when we went through the player variables, we said there were 2 different speeds. So you've got the speed there for the left, and when you're moving forward, there's a different speed variable to be adding, and that's where this is being used. So when you press the right key and you're moving forward, you're moving a little bit faster than what you would up, back, up, left and down. And again, we set the boost flag there, so that's where it triggers that in the draw code that we've already gone through. So that's how that works. So this PXT, I'm not actually, when you're pressing the keys, I'm not actually changing the variable of the current player X and Y position, and PXT actually stands for target, player X target, and the same with Y, the player Y target. So this P speed times delta time. For level 1, PXT at this point would be around 10, I believe. And I'll show you how that's used further down. So as the game's running, PXT and PYT, when the player's not moving, these have the same values as the actual PX and PY variables. So that you could see these as a copy, and when you press a key, I'm changing the values of those. PXT actually stands for the player X target, so it's the target location of where I want to move the ship on screen. And that's all based around what the P speed is and what the delta time is. So for a level 1 ship, I know this works out at around 10 pixels, or 10 in value. So if you think about this coming in here and you've got the left key pressed, it would take off 10 from what the current value of PXT is, and if you're from a standing position, that would be about 10 pixels in difference at this point in the code. And as you drop down to the bit of code that then looks at applying that to the current player position, it's just these pieces, these 4 lines here do that, and you can see there that the player X target is taken away from the current player X position, and that's getting times by this value PMS, and that sort of controls, it reduces this value at a slower rate, and the result of that gives you the actual amount to apply to the actual position of the player X and player Y. And the PMS actually gives you the ability to control how quickly that slowdown is. Um, it's sort of the friction of the movement, and you can mess around with this value here, and you'll get a completely different um, movement of the ship. And let me see if I can show you that just by changing this value. Let me find what that defaults at. It's defaulted here to 8. And that doesn't change within the game because that smoothness or the friction of the ship doesn't change. It is actually used elsewhere in the player ship movements, but let me change it. So I'll just change it on the X side of things. If we put that to, let's say, 15. You'll see how that alters the movement. So if I move up and down, nothing's changed, but if I move forward, you see how quickly that stops now. Same with back. So it's more sudden, but the up and down has still got that smooth. So by increasing that number, you lose that smoothness or that friction. And if I bring it down to maybe 3, you'll see that it slides around a lot more. See how that keeps moving for a longer period of time, rather than the up down, it's a little bit quicker, so it slides around a bit more. And if you want it a little bit lower, see the difference now. So it takes longer to get up to speed. So I've let go now. It takes a lot longer to come to a standstill. So you can see how you can adjust that to get the movement that you want. So I'll put that back. So yeah, the result of that little calculation there gives you a value that then we can use to apply to the ship's position. So you can see how that's working. So when you've got a key down, this is adding the target, keeps adding this to the target, and then as soon as you don't press anything, obviously this target doesn't change. So this value between those two values, that starts reducing, and then it uses this multiplier to get that down to where the target and the player X would come down to sort of 0, and then the speed X would end up being 0, and then the position of the actual position of the ship would result at 0 as well. So you can hope that you can figure out how that's doing that. Something that I did skip over, just this bit of code here, as the comment says, it just keeps them within the screen bounds. So it's just using the display width and height to keep the player ship on screen. And the last key we didn't speak about there is the spacebar for player shooting, and it's just using a couple of variables just to control the rate of fire. So if you've got the spacebar held down, you wouldn't want it to be firing off a bullet every frame. So this just controls the rate of fire, and it uses the value in this variable to trigger that. shoot routine. Now the player bullets, I won't go through this because this is, oops, this bit of code here is just checking collisions with the player enemies and the player ships, and I'll do that in a separate video. But it's, you can see it's using bob call to check against a number of bobs. And like I say, I'll go into that in another video. So that's for player shooting. If I go up to where I've declared my variables, I've got these set of arrays that look after the bullets. So the maximum number of bullets that I've allowed on screen is 50. Based on me playing around, I've worked out that I'll never have more than 50 on screen, even with the fastest rate of fire. So I know I need 50. And you've also got these other variables here that are used for the animation. There's one there for the hit points, so that's how many hit points to apply to an enemy if the bullet hits an enemy ship. And I'm using the same sort of technique for the image indexes for the bullets. As you know, there's different weapons, so there's different images for different weapons. So again, I'm using the same technique in the way that I've numbered my images. And if I have just have a revisit of the images folder, so that's saying the base image is 200. So if we look at 200, you can see there, that's the base image index for, I think that's the level 1 weapon. And you see the frames there, you've got four frames there. That's the muzzle flash. So that's what gets played when you first fire the bullet, and that gets shown at the front of the ship. The next image is always what's shown as the bullet is moving through the space. And then when the bullet hits something, you've got another set of images on the end of that, and those images are shown as an animation at the hit point. And I've got a similar thing for the other weapons in the game. So you can see there, you've got 4 images for the muzzle flash of that weapon. You've got the weapon as it is in space, and then you've got the hit animation. And again, there's 5 different weapons. You can see all the frames there are there for them. So that's what the BWII is for. So to get those on screen and all moving independently, you need to be able to know what the screen locations of those are. So I've set up these variables to handle all that. And the key one is the bullet status. And I'm just using these values within that. So 0 means it's not in use, or it's dead, or it's basically not being used, or that array element isn't a live bullet on the screen. 1 means that it's a live bullet. So in my draw routine for putting these bullets on screen, I basically need to have a look for only the ones that are set to 1, and I know that one needs to be put on screen and moved. When it's a 2, it means that it's hit some terrain or it's hit an enemy ship. So that's just a way for me to be able to code the explosion animation or the hit animation for the bullet, and also apply damage to whatever it's hit, if it's a ship or an enemy. Obviously, if it's hit terrain, then I'm just showing the hit animation, which is the 4 frames that I said. Them 4 frames at the location of where it hit something. So you got bullet X, bullets Y, so that's just the X and Y positions, and the bullet speed, so that's the X speed. So bullets always move from left to right, so I don't need an X and Y speed, it's just one speed. And bullet frame, so that's the current frame that would be played at the position of the bullet. And as you can imagine, depending on what stage of the bullet is, it's going to be one of these image numbers. So as it's flying through the air, it would be 204 for that particular bullet, and if it's showing the muzzle flash, it would be one of these. And so what we've also got in this array, because we have different frames for different types of bullets, we've got the start frame, an end frame, and so the start and end frame is basically the muzzle flash part of the animation. The code that looks after when it hits something is separate to this, which I'll show you that as we get to that part. So these are the arrays here, and you can see that I'm dimensioning those to whatever value I've put in the max bullets, which is 50 for this one. So we've got all those arrays sized at being able to hold 50 elements. So let's have a look at the player shoot. So the players press the space bar, it's triggered this player shoot routine. So the first thing I need to do is look in that array and find an array element that's not in use. And so this is what the for next loop is doing here. It starts at the beginning of the array, starts at position 0, and it's going to loop all the way to the end of whatever the max bullets is set at. So this is going to loop from 0 to 49. And so it'll check the status first. If it's 0, then it basically says, right, I've got a free array element to use, and I can then set up all the rest of the array elements that I need to set up for that bullet to be put on screen. So, you know, as soon as I set this to 1 in the update bullets routine and the draw bullets, they're only looking for array elements that have got a value of 1. And because when you shoot, you're only shooting one bullet at a time, so once it's found one that's got a 0, there's no need to continue looping to the end of the for next loop. So to jump out of this for next loop, I'm just setting PS to what the max bullets -1 would be, and that causes this for next loop to complete, and it'll jump out of there. So hopefully you can understand how that works. So if you just fire one bullet, it'll just drop into here, find the first element that's free, set up these variables, and then exit out of there. So the bullet X and bullets Y, so I'm basically using the current ship PX and PY value. I'm adding on to that what the weapon offset is, and also what the bullet offset is. So the weapon offset changes based on what ship you've got. So again, this just works out where the front of the where the weapon source point should be on the ship, and these two variables change based on what weapon and what ship you've got. So that allows me to put the bullet in the right place on the ship. So that's that. that's how I'm spawning bullets. That's basically a spawn routine. And then in the update bullets, again, what this does, it actually loops through all the array elements. So this will loop through all the 50, look for any element where the bullet status is not 0. So, like I said, this sets that to 1 there, so that triggers this routine to actually do something with that particular array element. So the first thing this is doing, it's checking to see if the bullet has collided with the terrain. So in the same way as what I'm doing with the player ship, this is just looking at the location in the map for the current bullet X and Y position to see what tile is under there. If it's not a 0, then it's setting the bullet status to 2. And we said there that 2 is exploding, so it doesn't remove it off the screen at that point. It just sets a different status so that we know in the draw routine that we can stop moving that bullet to the right, and we just need to show the bullet explosion animation, and then it can be removed. So that's what that's doing. It's just using the get tile value, and like I said, it sets it to 2. It just clears off the frame, sets that back to 0, and what it then does, it knows that in the images for the player bullets, what do we say, 200? Yeah, so 200, it knows that whatever the base image index is, we add 5 to that to get to the start of the start frame of the bullet explosion animation. So it's adding 5, and the end frame is whatever the base image is plus 8. So it basically, it's setting the values of that and that image, so that in the draw routine it knows just to go through them frames before removing it out of the array and setting the status of that back to 0. So when it's hit the terrain, I'm just moving the X position of the bullet to the edge of the actual cell, or to the middle of the cell, just to try and move the position to where it's actually hit, and then playing an audio sample. You can probably figure out that where this X position isn't very accurate, so it doesn't actually, it's not looking at the actual the tile itself to work out, whereabouts in the tile it's hit the image. And this is why I've got this mod 32, just to move that slightly to give it to make it look like it's actually hitting the terrain in the right place. Let's see if we can see that. Wait for someone to come in. You can see it's actually, the hit position sort of changes. And for this particular game, if you wanted that to constantly hit the actual position of the terrain, then you'd have to, you could probably figure that out using the position of the map. I might actually do that at some point, just to figure out that actual X position of where that explosion or that hit position needs to be. And you can see there that because these cells are sort of 64 by 64 pixels, it sometimes looks like it's it's hitting a cell there when there's no terrain underneath it. But that's not really a big deal for this type of game. I can sort of get away with it for this. So that's how the collision detection with the terrain is being done. And it's a similar thing with the ground enemies, but it's using bob call because they're bobs where the terrain isn't. I'll go into that in more detail when I do the video on the ground enemies and enemy ships. And then further down, this is where it's looking after the animation side of things. And so first thing it does, if the bullet frame is 0, it sets it to whatever the value is in the start frame array. And that basically, this is what happens when you first press the fire or press space. It sets that back to 0, and then this piece of code just sets that up as being whatever's in the start frame. So when the status is 1, what it'll do initially is check to see if the current frame is the same as the end frame, and when the bullet is going through the muzzle flash animation, it doesn't want to be moving away from the ship. So for those four first frames, the position or the X position needs to be wherever the front of the ship is. So that's what this if and else is doing here, until it gets to that end frame. So until it gets to this frame 2 or 3, all it's doing is get this right. Yeah, it's keeping the position here to be the same as wherever the front of the ship is, and then it's incrementing the actual bullet frame. So it'll go from there to there, and then once it's done that, it'll be on this frame 204, and that's when it'll start moving the bullet across the screen. And then, like I said, when it hits the terrain and we set the bullet status to 2 here, down here, when it comes across a bullet that's got a status of 2, it'll then cycle through the end frames, or cycle through the frames, and once it's got to the end frame, which would be, for this particular bullet, it would be 208. Once it's got to there, it sets the array element to 0. In effect, that frees that up to be used for another bullet, and also it stops that bullet from being put on the screen in this routine, further up in this routine, and then it just removes the bob off the screen there. So I'm adding 50 to the I, so because we're looping through this array from 0 or from 0 to there, I know that I'm using bobs 50 to 100 for the player bullets, so that's why I'm adding the 50 there to remove the bob that relates to this particular array element. And then just the last piece of code, the bullet could end up going off the right side of the screen. So if the X position is greater than the display width, I'm again setting the status to 0 to free that one up, and also removing that the bob number that relates to that element off the screen as well. And the draw bullets, pretty simple really. We're just looping through the full array, and if it finds any that have got a status greater than 0, it's using the, like I said, 50 is from 50 to 100 is what I'm using for the player bullets. So I'm just adding whatever the I is, the I variable to that, to put that on the screen, and it's just using the XY and whatever image number is currently in the bullet frame array. So that technique of having this array set up with all these different items, or a different multi-dimensional array for the different properties, if you like, that's my approach. I've also used for the enemies and the enemy ships. I've basically got a list of of array elements that store all the different items for what's needed to animate and move and shoot and everything else for each type of object that I've got in the game. So hopefully you can understand how that works. Yep, okay, so hope you've enjoyed that. Hope it's given you a bit of insight, and I'll be back with another video going through the enemies. Alright, thanks for watching, cheers.